All this other stuff, unless you become a mathematician, you're never going to see it again. Okay? It's numerical analysis uses these formulas. I really wouldn't worry about it. I would, for you guys, concentrate on this. Okay? Now, to decide what degree my polynomial is, look at the exponent of the variable. Okay? So this one doesn't even have a variable, so it's degree 0, and I would just have a constant or a number. So even a number 1 to have, that notes just degree 0. Linear, dealt with, just put it in them. You guys have worked with linear equations. Algebra 1 worked with, 90% of the time you worked with linear equations. What's a linear equation? Don't forget, if there's no exponent there, it's a 1. So it's degree 1. It's a line, right?
Are we getting a quiz review on Thursday?
Yes.
Wednesday
tomorrow. So degree 1, and we denote that by saying degree 1, so d equals 1 is a linear equation. Okay, degree 2, or d, is called a quadratic equation. We've been working with quadratics. What shape? Yes, you're right, a parabola. Sometimes the U shape goes up, sometimes. Degree 3. It's a cubic polynomial. I'm not sure if we did work polynomials last semester or not. Does anybody know the shape of a cubic? It's kind of goes like this. Yeah, that's a cubic. Degree 3. Degree 4 is called a quartic. Degree 5 is called a quintic. And degree 6 and above, we just say degree 6, degree 7, degree 8, degree 9. There's no special names. This is a cubic shape. It's important. Pardon me? Yes. Yeah. I'm sorry. These are just sketches, all right? All right, so let's figure out. They give us 1 through 4. They bust some polynomials, and we're supposed to figure out what degree and type is in the leading coefficient. This is pretty easy stuff. Now, when you're working with polynomials, you should always put them in standard, which is nothing more than highest degree to lowest degree, right? Here's my highest degree, negative 3x to the 4th, because my exponent's 4 for the variable. And then my next smallest variable is exponent is 2, so I have plus 1/2 x squared minus 7. What's my degree? That's right, 4. What type is that called? Well, 4 is quartic. And what's my leading coefficient of this polynomial? That's right, negative 3. Because my largest exponent for the variable is 4. Okay. What about number 2? Well, actually, it's already in standard form, isn't it? 2x cubed plus 4x squared. What's my degree? That's right, 3. What's 3 called? Cubic. And what's my leading coefficient of this polynomial? Good. Number 3. What's my first term? That's right, 2x to the 5th. My next one's going to be plus 6x squared plus x. It's degree 5. And it is a quintic. My leading coefficient, 2. And the last one, what's my first term? Pi x squared, good. What's my next one? Negative 0.5x, and my last one, minus square root of 2. What's the degree? Alana, what's the degree? Good. You got it. 2 is called a quadratic. And what's my leading coefficient? Pi. Okay, evaluating functions. Everybody learned this back in Algebra 1, right? They give us a function here. And they tell us to evaluate it when x equals 3. So, wherever I see an x, that's where I substitute in a 3. Now, when you do this, always put parentheses in for that value, because it will come and bite you in the butt if you don't. Okay? Everybody, by the way, you're going to need calculators for this section. Somebody put that in a calculator and tell me what they get. Nah, I'm too lazy. Anybody? 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 98. Good. All right. What about number 6? X equals negative 4. So wherever I see an x, I substitute in negative 4. So the f of negative 4 equals 3 times negative 4 minus 5, which equals negative 17. If you just plug it in the calculator and puts negative 17 down, I'm good for that. I'm good with that. Huh? I just do because it just looks right to me. Yeah, if you put negative 17, that's the evaluation. The full function notation would be the f of negative 4 equals negative 17. All right, number 7. My x equals 1, so I need to plug that in. 1 minus 2. Everybody remember where the absolute value key is on their calculator? Me neither. Okay, so 3, I think it's the math key. Go over to num and hit enter. Absolute value, 1 minus 2. And I get 3. College, I went to a lot of different colleges. I graduated with my teaching degree from Northern. I have a lot of vocational degrees. I don't care to answer your question. How do you like that? What? Yeah, that's what I got my degrees in, women's studies. You're a doorknob. Thank you. I don't like doing this store thing, so I'm not even going to teach you that. Okay, ready? No, we haven't done anything new. You should. This is all algebra 1. Come on. What? Doorknobs, doorknobs, doorknobs. Doorknobs, doorknobs. Okay. When you see end behavior of a polynomial, that means what's the behavior going off the graph? What is it end? What's happening? When you see end behavior, use this template. What? Yeah. Whenever you see the words end behavior, immediately write this down, because this is the way that you have to write it or present it. Now, if I'm talking about this, the way this is read is as you have a function, whether it's a parabola. Let's say we have a parabola. Okay. The way this is read is you kind of read this part first, then you use common sense for what's happening with this part. So as x goes to negative infinity, or in other words, as x goes to negative infinity to the left, what's happening to my y? Going to positive infinity. Okay? This says as x goes to positive infinity, so this is going to the right, what's happening to my y? Positive infinity. Okay. Now notice, this is y equals x squared. Okay, that's a parabola. That's the parent graph for a parabola. The end behavior for all parabolas.
Right, his parents would be oh so proud of him.
The end behavior for all parabolas, that means anything that's even, to the second, to the fourth, to the sixth, to the eighth, so on and so forth, with a positive coefficient. Okay, guys, write down. Notice the coefficient's a positive 1. Will always be positive infinity, positive infinity. Now, if I have a negative coefficient, the blanks are going to be what? Your y values are going to be negative infinity. Negative infinity. Okay? And behavior for a negative coefficient is going to be negative infinity, negative infinity. So when I'm looking at even integers for your exponents of the variable, it's going to be positive infinity for your end behavior. If I'm talking about an odd polynomial, this is y equals x cubed, right? So as x goes to the right, as x goes to the left, negative infinity, the f of x, or y, approaches what? If it goes to the left, my y is going to approach negative infinity. As my x approaches positive infinity, my y is going to approach, so if I go to the right, it's going to go positive. And that's going to work for all odds. So all odds with the positive coefficient, it's going to be the same. See how these are the same? Negative, negative, positive, positive. And of course, it's going to be the same with the line, except there's an exception with the line thing. We're not going to go into it. Y equals x to the first. That's a linear equation, right? It's just a line. So it's going to be negative infinity, positive infinity. It's the same thing as the odds, except there's an exception when we have a vertical line. So in number 7, it says sketch the graph and come up with the end behavior. Well, I already know that this is an odd integer, so I need my template. A fancy way of saying x goes to the left. What happens to y? Y approaches blank as x goes to the right. So whenever you see end behavior, you automatically write that down. All you have to fill out are the 2 blanks. Well, this is an odd integer, so I know that these are going to be the same. Now, another way you could do this, put it in your calculator under the y equals button. In fact, this is the way you're supposed to do it, but mine's a shortcut. So I have 4x, graph it. Notice, as my x goes to the left, or negative infinity, my y goes to negative infinity. As my x goes to positive infinity, my y goes to positive infinity. I think it's just easier to remember that if it's odd, it's the same. If it's even, so figure out what end behavior is. As x goes to the left, what happens to my parabola? Now be careful with this. Because I have a negative coefficient, it's not going to be positive infinity, positive infinity. It's going to be negative infinity, negative infinity. Because if we sketch this graph, negative 4x squared, it's going to be a parabola that opens downward, right? Be careful, sometimes they ask you to sketch the graph. And do that, just do a quick sketch, nothing real fancy. Okay. End behavior for this. As x goes to the left. And then we have to do as x goes to the right. If you want to, go ahead and put it in your calculators. See, I've got negative x cubed plus 5x minus 1. Graph it. So as I go to the left, my y goes positive. As I go to the right, my y goes negative. All right, domain and range. Again, you can put it in your calculators and figure out what the domains are. Let's make it easy. If I have an odd exponent, my domain is going to be negative infinity to positive infinity. My range is going to be negative infinity to positive infinity. If I have an odd exponent, it's going to be negative infinity to positive infinity for both domain and range. And if you don't believe me, go ahead and put it in. Okay. It will always be negative infinity for your domain and your range. The hard ones come when we have even integers. Even integers, you have to put in your calculators. Even exponents, integer exponents, you have to use your calculator. Okay. All right, so my polynomial here is x squared plus 3. It's an even exponent, so I have to put in my calculator, x squared plus 3, graph it. My domains for all parabolas are what? Negative infinity, positive infinity. That we don't have to figure out. That's your end behavior, actually, for all parabolas, is your domains. The one part you do have to figure out is your range. Where does it start on your parabolas? And the reason why we have that, because we either have a minimum or max. This one has a minimum. We have to calculate what that minimum is. And this one happens to be pretty easy. It will be in the chart, but 9 times out of 10, you're going to have to do the left bound, right bound thing. So we need to find the minimum, left bound, enter, right bound, enter, and hit enter. And it tells us it's at 3. Y equals 3. That's where it starts. It includes the point 3. This one, they want us to sketch the graph, opens upward. So it goes to positive infinity. Now the next one, you're going to have some work to do too. It's not going to be so easy. Put it in our calculator. 2x raised to the 4th plus 3x squared, cubed, plus 1. Graph it. It should have 2 bumps. There we go. Every time we go up, like to the 4th, to the 6th would have 3 bumps. We need to find the minimum here, right? I'm going to blow this up a little bit.
Whoa.
Okay, so I need the second trace. I need to find the minimum. I need to find the smallest minimum, which is there. So I'm going to go to the left bound, hit enter. I'm going to go to the right bound, hit enter again. And it starts at negative 0.07. Negative 0.07 includes that point. Looks something like a W. And then it's going to go up to positive infinity. Okay? End behavior, domain and range. The only time you have to really worry about domain and range calculating it is if you have an even integer exponent. I keep saying integer because there's a reason for it. And then the odds, just put negative and positive because it's always, oh, they want a sketch. Well, on your homework, yeah, it did. On your homework, I would do problems 3 through 6 right now because those you need to do on the calculator. Make sure you put end behavior on 3 through 6. You have like 6-7 minutes left. You can get those easily done.